What if I told you that humanity's best chance of surviving the next century is 384,000 kilometers away? Not Mars, at least not now, not a space station, but the moon, a silent, cratered world we haven't set foot on in over 50 years. Now we're going back to stay. For survival and expansion, the moon may hold the keys to unlocking our future in space. Let's break it down. First, location. The moon is close. Just a 3-day trip. That's a cosmic neighbor compared to the months it takes to reach Mars. If something goes wrong, rescue is possible. But it's also far enough to learn how to live off Earth permanently. Next, water. Billions of tons of frozen water ice lie trapped in permanently shadowed craters at the lunar poles. This isn't just for drinking. Water can be split into hydrogen and oxygen, the very ingredients for rocket fuel. It can also support plant growth, generate breathable air, and maintain life support systems. Now, let's talk about resources. The moon is loaded with rare and useful materials. For example, titanium, thorium, aluminum, silicon, and iron. These aren't just rocks, they're the raw ingredients for a functioning base, space manufacturing, and even future space economies. Some of these metals are increasingly rare on Earth but essential for electronics, batteries, and advanced technologies. And perhaps most exciting, helium-3. Helium-3 is a rare isotope brought to the moon by the solar wind. On Earth, it's virtually non-existent, but in theory, helium-3 could be used in nuclear fusion, generating massive amounts of energy with virtually no radiation or waste. It's not ready yet, but it could be the clean power source of the future. And the moon may hold over 1 million tons of it. A future moon economy could be built around harvesting helium-3 for energy-hungry civilizations back on Earth. So how do we build a base there? The answer: robots and regolith. Instead of launching heavy building materials from Earth, we can send autonomous machines. They can 3D print structures using lunar soil, called regolith, to form bricks, concrete, and even radiation-resistant walls. This reduces costs and takes advantage of what's already there. Some scientists even suggest building underground, inside lunar lava tubes formed by ancient volcanic activity. These natural tunnels could offer protection from radiation, micrometeorites, and extreme temperatures. We wouldn't need to build bunkers, we'd just adapt the ones the moon already made, but we're just getting started. Because the moon's weak gravity, just 1/6 of Earth's, opens up crazy possibilities. Like a space elevator, that's right. On Earth, it's science fiction. But on the moon, it's surprisingly feasible. With no atmosphere and lower gravity, a tether stretching from the lunar surface to orbit could transport cargo without rockets. Fuel, metals, equipment lifted silently and cheaply into space. This would change everything, and scientists have already proposed multiple designs for how such a lunar elevator could be anchored and stabilized. Because ultimately, the moon isn't our destination. It's our gateway. Launching rockets from Earth is expensive. Gravity is a brutal opponent, but from the moon, it's 6 times easier. If we produce fuel from lunar ice, we could turn the moon into a refueling station. From there, spacecraft could head to Mars, the asteroid belt, or even the outer solar system, using less fuel and less money. That's why NASA is building the Lunar Gateway, a small space station orbiting the moon. It will serve as a deep space hub, a rest stop, lab, launch pad. Astronauts could dock, refuel, perform repairs, and launch to Mars at the perfect moment, all without returning to Earth. But Lunar Gateway is more than a pit stop. It's a dress rehearsal for deep space living. Crews will test life support systems, run long-duration experiments, simulate Mars surface missions, and learn how to thrive away from Earth's safety net. It's a platform for engineering, biology, psychology, all under deep space conditions. And that brings us to the most important reason: survival. Earth is fragile. We've had mass extinctions, asteroid strikes, supervolcanoes, and we will again. Even today, war, pandemics, and climate change remind us how quickly life can be disrupted. A moon base gives us insurance, a second home, A place to store knowledge, preserve biodiversity, and reboot civilization if the worst happens. No earthquakes, no hurricanes, no borders. Just rock, ice, and potential, so when people ask, why go to the moon? Flip the question, can we afford not to? For the first time in human history, we have the technology to become interplanetary, to move from being a one-planet species to a multi-world civilization. The first baby born on the moon will mark a turning point. A human whose home was never Earth. What kind of society, language, or perspective might emerge from living on another world? And it all starts with the moon.